Hello friends, once again, welcome to my YouTube channel. First of all, I thank you for taking your valuable time and interest in watching these laboratory based video. So to begin with, in this video, I'll show you the procedures for estimations of total hardness in water samples by adopting the EDTA titration method. So for your convenience and information, the different topic that will cover under this video will fall under the following. First, we'll have a short introduction to total hardness, and in stage 2, we'll see the formula used for calculation of total hardness, and in stage 3, I'll demonstrate you the step-by-step procedures for preparation of reagents used in the analysis of total hardness, and in stage 4 I'll demonstrate you the procedure for standardizations of EDTA solution, and in stage 5 I'll do the analysis of total hardness in water samples, and last but not the least, in stage 6 I'll show you how to calculate the total hardness of any water samples using Microsoft Excel. Now let us try to understand a little bit about the total hardness. Total hardness is one of the major chemical parameters used for in any water quality analysis. And basically the total hardness generate information about how easy that water produce leather with soap. I think you have come across that some water, when you apply soap while washing hands, sometimes the lather doesn't form. That is because the water that you're using or washing your hand with is hard. Total hardness of water is basically due to the presence of the varieties of dissolved minerals present in the water, and they are predominantly calcium and magnesium cations. And you also have to remember that total hardness is always expressed in terms of calcium carbonate in milligrams per liter. For your information, there are two types of hardness in water. The first one is called the temporary hardness, or also known as the carbonate hardness. This type of hardness is caused basically by the presence of dissolved form of calcium bicarbonate and magnesium bicarbonate in the water. However, they can be easily removed by boiling the water. And the second type of hardness is called the permanent hardness or the non-carbonate hardness. And this is attributed mainly by the presence of the sulfate, chloride ions and nitrate ions of calcium and magnesium. However, with respect, this type of hardness cannot be removed by just boiling the water. Next, based on the degree of hardness that the water exhibits, then that water samples can be classified into one of these 4 different categories. So any water that you sample will be either soft water, or maybe moderately hard water, or maybe a hard water, or a very hard water. For example, if the hardness value ranges from 0 to 75 milligram per liter, then that water will be indicated as a soft water. Now let's move on to the next stage, that is stage number 2, where we'll see the formula used for calculation of total hardness. As I've already mentioned earlier, total hardness is always expressed in terms of calcium carbonate in milligrams per liter. So the formula for total hardness is equal to A into B into 1000 divided by ml of samples, where A is equal to the ml of EDTA required by the samples for titration, that is the value obtained from the burette reading, and B is equal to the milligrams of calcium carbonate equivalent to 1 ml of EDTA. For your information, the B value will be obtained after standardization of EDTA with the standard calcium solution. Okay. Next, let's move on to the next stage, that is preparations of reagents required for analysis of total hardness. Before we proceed into the preparations of chemical reagents, for your information, there are 2 points that I would like to share with you. Point number 1 is the procedures that I am adopting for demonstration purposes in this video is as per the standard protocol prescribed by MIT and AFA. And point number 2, to avoid wastage of chemical, prepare the required reagent using minimum amount of chemicals. However, this might change if you have a lot of samples to analyze. For example, if the prescribed book says that dissolve 364 gram of X chemical in 1 liter of water, and if you have only few number of samples, then you don't need to prepare 1 liter of a reagent. So instead, you can weight on 36.4 grams of the X chemicals and dilute it in 100 ml of distilled water. So this is how you can avoid wastage of chemicals during preparation of reagents. The first reagent that we are going to prepare is standard calcium solution, which is of 0.01 normality. And for your information, this reagent is prepared so that we can use it for standardization of EDTA solution later on. Before we proceed, first let us prepare these two chemicals, that is hydrochloric 1 plus 1 and ammonium hydroxide solution, which is of 3 normality. And to do so, first let us prepare the hydrochloric acid 1 plus 1. To prepare this solution, take the hydrochloric acid and from it we put 5 ml into a 100 ml beaker, and then take a distilled water and we put 5 ml of distilled water into the same beaker and mix the solution, and this will give you a hydrochloric acid which is of 1:1. Next, let's move on to the preparations of a 3 normality ammonium hydroxide solution. And to do so, first measure 10 ml of ammonia solution by using a 10 ml measuring cylinder, and then pour this into a 50 ml volumetric flask. And after doing so, fill the volumetric flask with distilled water up to the mark. And this solution will give us a 3 normality ammonium hydroxide solution. Now once these chemicals are prepared, now we can start the preparation of standard calcium solution. For the preparation of standard calcium solution, first take small amount of calcium carbonate into a petri dish and then dry it in an oven for 1 hour. Then 1 hour later, you can take out the calcium carbonate from the oven and then cool it inside a desiccator. After some time, take it out of the desiccator and then weigh accurately 0.25 gram of this calcium carbonate and then pour it into a 250 ml volumetric flask. Then to it add the prepared hydrochloric acid till the calcium carbonate is completely dissolved. Then once the calcium carbonate is dissolved inside the volumetric flask, next add 50 ml of distilled water into it. After this, place the volumetric flask in a heater and boil this solution for few minutes. And after boiling it, cool the solution. And once the solution is cool, next you can add 2 to 3 drops of methyl red indicator. You see that the solution turns pink in color. And after that, add the ammonium hydroxide solution into the pink color solution till some intermediate color appears. Once the color changes, then you fill the volumetric flask with distilled water up to the marks. Then once this is done, then this solution will be used for standardizations of EDTA solution. The normality of this solution will be 0.01 normality, and 1 ml of this prepared solution will contain 1 milligram of calcium carbonate. Remember this will be useful later on when we're trying to find out the B value of the formula. Okay. Next, let's move on to preparation of reagent number 2, that is the inhibitor. And to do so, the chemical required for the preparation of inhibitor used in total hardness analysis are hydroxylamine hydrochloride and ethyl alcohol. To do so, measure 0.75 grams of hydroxylamine hydrochloride and then transfer it into a 100 ml conical flask, and then measure 50 ml of ethyl alcohol using measuring cylinder, and then pour the measured ethyl alcohol into the conical flask containing the hydroxyl amine hydrochloride. Then mix the solution thoroughly and then seal it with a parafilm, and this solution is an inhibitor that will be used for the analysis of total hardness in water samples. Next, let's move on to preparation of reagent number 3, that is the preparation of erichrome black tea indicator. And to do so, the chemical required are, you need erichrome black tea and alcohol. To prepare this reagent, first weigh 0.25 gram of erichrome black tea and then transfer it into a bottle, and then measure 50 ml of alcohol using a measuring cylinder, and then pour the alcohol into the bottle containing the erichrome black tea. Then mix the solution thoroughly. Then this solution is an erichrome black tea indicator. Next, let's move on to the preparations of reagent number 4, that is buffer solution. For the preparation of the buffer solution, the chemical required are ammonium chloride, concentrated ammonium hydroxide, disodium EDTA salt, and magnesium sulfate. Now let's start preparing the buffer solution. To do so, there are two steps involved. The first step is, first of all, measure 16.9 grams of ammonium chloride using a 100 ml beaker. Next, transfer it into a 250 ml beaker. Then, using 100 ml measuring cylinder, measure 143 ml of ammonium solution. Pour it into the 250 ml beaker containing the ammonium chloride. After doing so, you can mix the solution thoroughly. Then once this is done, let it stand till all the salts are totally dissolved. Next, let's move on to step number 2. First, measure 1.179 grams of disodium EDTA salts and then transfer it into a 100 ml conical flask and measure 0.78 gram of magnesium sulfate and then transfer it to the 100 ml conical flask containing the disodium EDTA. Then add 50 ml of distilled water into it and then mix it thoroughly. The next stage is transfer the solution from step 1 and step 2 into a 250 ml volumetric flask by using a funnel. Then fill the volumetric flask up to the mark with distilled water. Then mix the solution thoroughly. Then once this is done, then this solution is ready for use, and this is the buffer solution that will be used for the analysis of total hardness in the water samples. Next, let's move on to the preparation of the last reagent, that is preparations of the EDTA solution, which is of 0.01 molarity. And for the preparation of the EDTA solution, first measure exactly 1.861 gram of disodium EDTA salt and then transfer it into a 500 ml volumetric flask. And once this is done, dilute the EDTA disodium salt with distilled water by filling the volumetric flask up to the mark. Once this is done, then this solution will be standardized against the 0.01 normality standard calcium solution. And interestingly, the volume of EDTA required to titrate the standard calcium solution will not only provide us the normality of the prepared EDTA, but it will also provide us the information about the B value from the total hardness formula. That is, in 1 ml of EDTA, how many mg of calcium carbonate is also present. Next, let's move on to the next stage, that is the standardization of EDTA solution with standard calcium solution. And to do this, first take the prepared standard calcium solution and measure 50 ml of the standard calcium solution using a 50 ml measuring cylinder and transfer it into a 250 ml conical flask. Do this in triplicates. After doing so, to each of the conical flasks, first add 2 ml of the prepared buffer solution, followed by 1 ml of the hydroxylamine hydrochloride inhibitor, followed by a few drops of Erichrome black tea indicator. The solution will change into pink. Next, titrate the pink color solution with EDTA solution till the pink color turns steel blue. And for every titration, record the initial and final Buryk reading. Repeat the same procedure for the other two replicates. Let the volume of EDTA required to titrate the standard calcium solution be as displayed on the screen. Let us assume that for replicate 1, the volume of EDTA required is 26.9. For replicate 2, it is 26.7 and replicate 3, 26.1. And the average EDTA required to titrate the calcium solution is 26.6 ml. Next, once this data is available, we can first cross-check the molarity of the EDTA solution, because if you remember, our prepared EDTA solution molarity should be 0.01 molarity. Let's do the EDTA molarity check. And to do this, we have to use the M1V1 is equal to M2V2 formula, where M1 is equal to the normality of the standard calcium solution, which is 0.01. V1 is the volume of standard calcium solution used, which is 50 ml. And M2 we have to find out, and V2 is the volume of EDTA used. So by using this formula, we can find out the M2 value. So M2 is equal to M1 V1 divided by V2. So M2 is equal to 0.01 into 50 divided by 26.6. And the final M2 value is equal to 0.018, which means that molarity of the prepared EDTA solution is equivalent to the desired EDTA molarity. Next, this data not only provide us the molarity check, we can also find out the B value from the total hardness formula. If you remember, for 1 ml of EDTA, we have to find out how many milligrams of calcium carbonate is present. So we have seen that 26.6 ml of EDTA is required to titrate the 50 ml of standard calcium solution. And if you remember, for the prepared standard calcium solution, for 1 ml of the standard calcium solution, 1 milligram of calcium carbonate is present. We have already mentioned that earlier. So what we have to do here is, we just have to do this mathematical calculation here. 26.6 ml of EDTA is equal to 50 ml into 1 milligram of calcium carbonate. So which means that from here we can derive for 1 ml of EDTA. So 1 ml of EDTA is equal to 50 into 1 divided by 26.6 milligram of calcium carbonate. So this will give us an answer that 1 ml of EDTA is equivalent to 1.87 milligram of calcium carbonate. So if you find this value 1.87 milligram of calcium carbonate, then this value will be the value which you will place for the value of B. So B is equal to 1.87. Okay, so this is very important, and most of the time most of the people ignore this portion. All right, next let's move on to the next stage, that is the analysis of the total hardness in the water samples. For demonstration purposes, let us determine the total hardness content of these water samples. And to do so, first let us take 50 ml of the water samples using a 50 ml measuring cylinder and then transfer it into a 250 ml conical flask. Always do the analysis in triplicates. Next, to each of the conical flasks containing 50 ml of the water samples, first add 2 ml of the buffer solution. It is then followed by the addition of 1 ml of hydroxyl amine hydrochloride indicator. Which is then followed by the addition of few drops of Erichrome black tea indicator. Once these indicators is added, you'll see that the solution turns pink in color. Now, once this stage is completed, then the next stage is the titration of the water samples with EDTA solution. Now, before we start the titration of the samples, first let us just transfer the prepared EDTA solution into the burette. Now, let us titrate the sample starting with replicate number 1. So take the samples and titrate it with the EDTA solution till the pink colors turn steel blue. And remember to always record the initial and the final burette reading. Then repeat for the replicate 2 and replicate 3. And let us assume that the data obtained during the titration is as displayed on the screen. And this is just for demonstration purpose so that you'll get an idea of how much ETDA is used during the titration of the samples. And this data will be used in the calculation stage shortly. Next, let's move on to the last stage, that is the calculation of the total hardness in the water samples with the help of Microsoft Excel. And to do so, open your Microsoft Excel and let's do the calculation. First, for easy calculation, let's bring the formula of total hardness in this Microsoft Excel sheet. As mentioned earlier, total hardness is always expressed in calcium carbonate in milligrams per liter and is equal to A into B into 1000 divided by ml of the samples, where A is the value that you'll get from the burette reading and B is the value that you will obtain after we standardize the EDTA solution with standard calcium solution, and then ml of the sample is how much samples we use for analysis. So to proceed further, let's bring the data that we obtain after the analysis of the water samples. So we have one water samples. So we have three replicates R1, R2 and R3, and the initial burette reading for first replicate is 0 and final burette reading is 9.1, and then for replicate 2 is 9.1, final reading is 17.8, and 17.8 for replicate 3 is the initial burette reading and 27.1 is the final burette reading. So from here we will obtain the A value of the formula. Okay, so A will be equal to final burette reading, which is this, minus the initial burette reading, which is this. So equal sign, this is how much you'll get. 9.1 for replicate 1, 8.7 for replicate 2 and 9.3 for replicate 3. So from here we have obtained for the A value. Now next let's find out for the B value. Remember the formula for B value is B stands for B is equal to milligram of calcium carbonate equivalent to 1 ml of EDTA, and this also we have already calculated. So from here, remember we found that 1 ml of EDTA is equal to 1.87 milligram of calcium carbonate. So therefore the B value will be equal to 1.87, and ml of the sample is the 50 ml of samples we use for analysis. So for therefore A will be this value, B is 1.87 and ml of sample is 50. So with that, it's very easy now. Just have to put equal sign A, which is this, into 1.87 into 1000 divided by 50. So this will give you the total hardness of the replicate 1, 2 and 3 respectively. So but from here we need to find out the average. From this calculation, we found that the mean value of total hardness is 337.85. So from here, if you remember that depending on the degree of hardness, what's the type of water is it? So based on this, the total hardness value is above 300. So which means that the water that we analyze is very hard water. So this is how you will obtain the information about how or what type of water is it. It is soft water, a moderately hard water, or a hard water, or a very hard water. So this is how you'll do the calculation, and you repeat the same procedure if you have n number of samples that you analyze. And for your information, this video is based on the procedures prescribed in the standard prescribed book for water analysis, and the reference are Mighty and Alpha. With that, we have come to an end of this video, and I believe this video will benefit and guide students in understanding the complete procedures of estimation of total hardness in any water samples by adopting the EDTA titration method. If you find this video helpful, please kindly like, share and subscribe to my channel. Your support is and will always be appreciated. Thank you so much once again, and God bless.